6-3, solving systems using elimination. Our objective, to solve systems by adding or subtracting to eliminate a variable. By the addition and subtraction properties of equality, if A is equal to B and C is equal to D, then A plus C equals B plus D, and A minus C is equal to B minus D. For example, 5 plus 1 equals 6, and 3 plus 4 equals 7. So 5 plus 1 plus 3 plus 4 equals 6 plus 7. In the elimination method, you use these properties to add or subtract equations in order to eliminate a variable in a system. Essential understanding. This is what's really important for you. There is more than one way to solve systems of equations. Some systems are written in a way that make eliminating a variable a good method to use. Problem number 1, solving a system by adding equations. What is the solution of the system? Use elimination. So we look at our equations here and we see 2x and 6x. But we notice we have a positive 5y and a negative 5y. So here's where our focus is. We want to eliminate that y so we can solve for x to find our ordered pair that both of these equations go through. So here we have our positive 5 and our minus 5 is 0. So now we have 8x, and when we combine 17 and negative 9, we get 8. So we added the two equations together. So our next algebra step is to divide both sides of the equation by 8. So now x is all by itself and is equal to 1. So in our ordered pair, x is 1. So x is equal to 1. So now we need to substitute 1 for x to solve for the eliminated variable. So we pick our equation and we put 1 in for x. We substitute it in. And we do our order of operations. We needed to multiply 2 times 1. We simplified. And then we subtract 2 from both sides, which gives us 15 divided by 5 is 3. So our ordered pair we have come up with is x is 1 and y is 3. So the solution is the ordered pair 1, 3. Problem 2, solving a system by subtracting equations. We have a multiple choice problem. The theater club sells a total of 101 tickets to its first play. A student ticket costs $1. An adult ticket costs $2.50. Total ticket sales are $164. How many student tickets were sold? So we need to focus on, well, the question, how many student tickets were sold? And that's where our multiple choice comes in. But we need to back up and write the two equations that are going to help us solve this. So we are going to let A equal the number of adult tickets and S equal the number of student tickets sold. We know if we take the student tickets and the adult tickets and add them together, it's 101. We know that it's $2.50 for the adult ticket and only $1 for the student ticket. So we don't need to write 1 in there. Remember, mathematicians don't do things twice. It's redundant to put a 1 there. You can see there's an S there, so there's 1 S there. So that takes care of your $1. And we know that the amount of money is $164. So you know that amount is going to go with the dollars, the cost. The 101 tickets is just adding those two together. Now we have our two equations. We need to do our system by solving our system by subtracting the equations. So we need to eliminate one variable. Since the difference of the coefficients of s is 0, we're going to eliminate s. So we're going to subtract everybody. So 1 minus $2.50 is a negative $1.50. So because we're subtracting, and we see this one's larger, so we're going to end up with a negative down here also. We subtracted, and then we divide by negative 1.5, and the answer A is equal to 42. So we need to substitute the 42 into the equation. Pick one of the equations, put 42 in. So we're going to subtract 42 from both sides of the equation, and s is equal to 59. There are 59 student tickets sold. The correct answer is C. When you run into reading in the book, it's really important that you do focus on it and not ignore it. And if you don't understand it, then when you come through it after you get going on the assignment, come back and read these again. It'll make more sense to you. So in problem 1 and 2, a variable is eliminated because the sum or difference of its coefficients is 0. From the multiplication property of equality, you know that you can multiply each side of the equation to get a new equation that is equivalent to the original. That is, a plus b is equal to c is equivalent to d times the quantity a plus b is equal to dc, or dA plus dB plus dC. Since this is true, you can eliminate the variable by adding or subtracting. If you first multiply an equation by an appropriate number, you can prove that the results are the same simply by substituting the values for the variable in the original equations to show that the equations are true. Okay, this is what it's telling you to do. In problem 3, solving a system by multiplying one equation. What is the solution of the system? Use elimination. So if we look closely at what x's, the coefficient is, we have a negative 2 and a 7. When we look here, we have a positive 15 and a negative 5. We know if we multiply this equation here by 3, this one eliminates. And that's our whole point, is to eliminate one of the variables. So we need to know the system of equations that can't quickly be solved by graphing or a solution. Need the solution of the system, and our plan is to multiply one or both of the equations by a constant so that the coefficients of one variable are the same or opposites, then eliminate the variable. Okay, so we noticed that this one is pretty close. We just need to multiply by 3. So we're only going to multiply this equation by 3. So 7 times 3 is 21. Negative 5 times 3 is negative 15. 17 times 3 is 51. So be careful when you're multiplying that each one of these terms get multiplied. And then we see, okay, we have the y variable is going to be eliminated. So we combine these two and we get 19x. We combine these two and get 19. And we divide both sides by 19. So x is 1. So we're halfway done. We have one of our numbers in our ordered pair. Okay, so x is equal to 1. Solve for the eliminated variable. Okay, so x is, we substitute in the 1, and now we're solving for y. So we subtract 7 from both sides, so we have 10 divided by negative 5 is negative 2. So our ordered pair is 1, -2. Okay, sometimes we're not going to see an obvious number to eliminate. And we can't see, oh, well, we just have to multiply by 3 like the last problem. So solving a system by multiplying both equations. So if we look at this, we see that there's nothing we can just easily add or subtract. We can't just multiply one equation, so we have to multiply both equations. So we notice that if we multiply this 2 by 3, we end up at 6, and this 3 by 2 will end up at 6. So we multiply the whole equation. 3 times 3 is 9, 2 times 3 is 6, 1 times 3 is 3, and then we're multiplying the next equation by 2. So we end up with 8x plus 6y and -4. So now we're going to subtract this equation to get this to eliminate. So 9 minus 8 is 1x. So it's real easy. X equals 7. Be careful here because we're subtracting. So 3 take away a -4 is the same as adding. So we end up at 7. So solve for the eliminated variable. So we substitute in 7 for x. We divide by 2, and y is equal to -10. So our ordered pair is 7, -10. Remember, we're looking for that point where these two equations go through, and they go through 7, -10. All that if you get a false statement as you solve a system, then the system has no solution. If you get an identity, then the system has infinitely many solutions because they're the same line. So find the number of solutions. How many solutions does this system have? So we multiply by 2 because we're going to subtract and get rid of this y, and we end up with 0 equals 0. Because 0 equals 0, it's an identity. There's infinitely many solutions. So if we solved for y, or even just multiplied this by a negative, we can see they're the exact same equation.